Welcome to today's deep dive.
hmm
So today we are pulling from this really fantastic article by Aaron Rose.
Right. The secret life of AWS S3 is more than a bucket.
Yeah, exactly. And, our mission for this session is, well, pretty straightforward. We want to help you fundamentally upgrade your S3 architecture.
Because, most people just see it as a basic digital storage locker,
Yeah,
right?
but we're moving way beyond that. We want to help you master these hidden mechanics that prevent catastrophic data loss, optimize massive cloud bills, and basically secure your most sensitive information.
Yeah, it's about getting past that surface level.
Exactly. So let's start with a nightmare scenario. Imagine a stray script runs in the wrong environment and it just overwrites your entire production configuration bucket with, like, blank files.
Oh, wow. Yeah, that is terrifying.
Right. And by default, that old data isn't just sitting in a recycling bin somewhere. It is permanently, unrecoverably gone. So today, we're unpacking why treating S3 like a simple, cardboard box in the cloud is just a recipe for an infrastructure disaster.
Well, what's really fascinating here is how Aaron Rose frames this exact realization in the source material. He uses this brilliant narrative device.
Oh, the mentoring conversation.
Yeah, exactly. It's set in this grand Victorian library in London between Margaret, who is this highly seasoned senior engineer, and her junior colleague, Timothy.
Right, and Timothy walks into this library feeling, like, incredibly confident.
Oh, completely. He knows the baseline definitions. He understands that S3 is an object store, not a file system.
He knows about the flat namespace, right?
Yeah, and that buckets are limitless. But Margaret just listens to him, nods, and then points out that he actually only understands about 10 to 15% of what S3 actually is.
He knows the shape of the tool, but he is completely blind to its actual substance.
Precisely.
Okay, let's unpack this, because that 10% illusion is exactly where so many teams live.
Yeah.
We just drop data into a bucket and assume the cloud will magically protect us from ourselves.
But as Margaret points out, the system simply executes the commands you give it. It doesn't think for you.
Right, which brings us back to that overwrite nightmare I mentioned. If S3 blindly executes a bad overwrite command, the only safety net standing between you and a massive outage is S3 versioning.
And what blows my mind about versioning is the actual mechanism behind how it handles deletions.
Yeah, because it doesn't actually delete the file from the disk, does it?
No, not at all. It basically just slaps a delete marker on top of the object. So it effectively hides it from standard API calls, but it keeps the data perfectly intact underneath.
So the architecture dictates that once versioning is enabled, every single action is appended rather than overwritten. You aren't replacing data, you are stacking it.
Right. Every upload, every tiny configuration tweak, it creates a new discrete object with its own unique version ID.
So if someone accidentally deletes a critical file, they're really just, like, putting a blanket over it.
Exactly. You simply remove that delete marker, and bam, the original file is instantly restored.
It functions like a universal undo button for your entire infrastructure. But I have to push back on this strategy a little bit.
Okay, go for it.
Well, if I'm running a highly active application, right, one that is constantly writing and updating state to an S3 object, like thousands of times an hour,
Yeah.
and the system is stacking every single microscopic change, my AWS bill is going to look like a phone number.
Yeah, you are not wrong.
Because I am paying for every single one of those stacked versions, aren't I?
You are paying for every byte of every version, absolutely, and that is a really fantastic catch.
It seems insanely expensive.
It can be, and Margaret makes this reality incredibly clear to Timothy in the story. The cost of versioning compounds rapidly with high write volumes.
So it's not a feature you just blindly turn on everywhere without understanding the economics of your data.
Exactly. However, she emphasizes a crucial engineering habit. You absolutely have to turn it on for your important buckets before the disaster happens.
Because it's off by default, right?
Huh?
Like most protective features, you have to actively opt in.
Yes. And flipping the switch after a deployment goes wrong recovers absolutely nothing. You have to anticipate the failure.
Right, so the fear of compounding storage costs shouldn't stop you from using versioning. It should just force you to manage your data lifecycle properly. You protect the data first, and then you optimize the cost.
Which brings us to the next massive architectural realization.
Right. We solved the data deletion problem, but in doing so, we've basically created a budget problem.
Exactly. Because if we are saving every version of every file, we clearly can't afford to pay premium top-tier prices to store all of it indefinitely.
Right, which leads us directly into the temperature spectrum of data.
Governed by S3 storage classes, yeah. The fundamental flaw in the beginner's mental model is assuming all data holds equal value forever.
Yeah, like when you create a bucket and drop a file in, it just defaults to S3 standard, right?
Right. That tier offers high availability and high durability. It's optimized for frequent access.
But it's also, the most expensive storage class per gigabyte. It is designed for hot data, things your application needs to read and write right now.
Yeah, so keeping a 3-year-old regulatory backup in S3 standard is literally just burning budget.
Which is precisely why Margaret introduces these temperature tiers.
Right. And, if you don't know your access patterns, AWS offers intelligent tiering. It just automatically moves objects between tiers for you based on how often they're touched.
Oh, that's incredibly handy.
It is. But when you do know your patterns, you can optimize much more aggressively.
Here's where it gets really interesting. I like to conceptualize this temperature spectrum like a wardrobe.
Oh, I like that.
Yeah, so S3 standard is your favorite winter jacket hanging on a hook right by the front door.
Right, you grab it every day.
Exactly. It takes up prime real estate, but the instant access makes that high cost totally worth it. But what about the next step down?
Well, the next step down is S3 standard IA, which stands for infrequent access. The actual storage cost drops significantly, but AWS introduces a retrieval fee.
Okay, so in the wardrobe analogy, standard IA is like putting a heavy raincoat in the back of your hall closet.
Yeah, exactly. It's cheaper real estate.
Right. But when a sudden storm hits and you actually need it, you have to spend a little effort, like a retrieval fee, to dig it out.
Perfect analogy. It's ideal for backups or disaster recovery files. You really hope you don't need them, but they are accessible if things go sideways.
And then the spectrum continues to cool down from there,
Yeah.
right?
We move into S3 Glacier. This is archival storage at a fraction of the cost, but the catch here is the latency.
Right, retrieval takes minutes or even hours, doesn't it?
It does. And then the absolute coldest tier is S3 Glacier Deep Archive. It offers the lowest cost per gigabyte in the entire ecosystem.
But retrieval is measured in hours. So to stick with the analogy, Deep Archive is like vacuum sealing your thickest coats in plastic bags and burying them under boxes in the furthest corner of your attic.
Yes, exactly. It is incredibly cheap to store them there.
But if a blizzard hits, you can't just grab them and walk out the door. It is a massive, time-consuming hassle to get them back.
Well, the physical reality of how AWS achieves those cost reductions kind of dictates that delay. Your data in Deep Archive isn't sitting on a hot server waiting for a rapid API ping.
It is deeply archived.
Right. It's designed specifically for data you're forced to retain, for regulatory compliance, audit logs, or historical records that you may literally never query again.
Which forces you to make deliberate decisions about the economics of your architecture over time. Think about application logs.
Oh, that's a perfect example.
Yeah, the logs your servers generated this morning are hot. You might query them 20 times today to troubleshoot a bug.
But next month,
You'll probably never look at them. Next year. Definitely not. But compliance requires you to hold them for 7 years.
and leaving 7 years of logs in S3 standard is just an incredibly expensive oversight.
But that highlights a major operational challenge. Recognizing that data cools down is one thing, but acting on it is another.
Yeah, because you cannot manually move millions of log files or old object versions down the temperature spectrum.
Right. Nobody has the time to log into the AWS console every Friday and transition files from standard to Glacier.
Which introduces the necessity of our next hidden mechanic, which is lifecycle policies. It's the automation of the entire data journey.
So a lifecycle policy is essentially a set of rules you define at the bucket level, and the system just handles the manual labor for you.
Exactly. It automatically transitions objects between those storage classes or even expires and deletes them permanently based entirely on their age.
And Margaret gives Timothy a crystal clear example of how this plays out in production, right?
She does. You configure a rule that says start the data in standard, then after 30 days of cooling off, automatically transition it to standard IA.
Okay, so it moves to the closet.
Right. Then, after 90 days, move it to the deep freeze of Glacier. And finally, after 7 years, when the regulatory requirement ends, permanently delete it to stop the billing entirely.
And it just runs in the background. No human intervention, no missed Friday cleanups.
Exactly. It matches the objects and shifts them down the temperature spectrum automatically.
But I have to challenge the actual utility of this for most of our listeners.
Okay, let's hear it.
Look, I completely understand why a streaming giant or a massive enterprise needs this.
Sure.
But if I am building a small side project or I'm at an early stage startup trying to find product market fit, spending time writing complex JSON lifecycle rules feels like the ultimate premature optimization.
I can see why you'd think that.
Right. Like, why shouldn't I just move fast, leave everything in standard, and wait until the storage bill actually hurts before I fix it?
Well, if we connect this to the bigger picture, waiting for the bill to hurt is a dangerous game because data only grows.
That's
Margaret's advice to Timothy here is a masterclass in senior engineering foresight. Small scale inevitably becomes large scale.
So the architectural habits you build when the project is tiny are the exact foundation you will be standing on when the project succeeds.
Exactly the point. If you fail to define lifecycle policies early, that oversight transforms directly into technical debt.
Ah, I see. So the bad habits compound just like the data compound.
Precisely. But unlike messy source code, which just annoys your developers, this technical debt is measured dollar for dollar in compounding monthly invoices.
Yeah, you really don't want to wake up one day and realize your startup's runway is being eaten alive because you are paying premium hot storage prices to hold on to 3-year-old error logs.
Exactly. It's an invisible leak in the boat.
Okay, so we've utilized versioning to save our data from accidental internal deletion, and we've implemented storage classes and lifecycle policies to prevent our own data from bankrupting us.
Right. So what is next?
Well, the final pillar of S3 mastery is protecting that data from the outside world. This brings us to S3's notoriously intimidating access control.
It is really intimidating, and Margaret states plainly to Timothy that the complexity is genuine.
AWS didn't just make it difficult to frustrate developers, right?
No, the complexity exists because the problem of determining who gets to read, write, or modify data in a globally accessible cloud environment is just inherently complex.
So what does this all mean for the person trying to secure their infrastructure? Because, I have stared at S3 permissions debugging screens and felt completely lost.
Oh, we all have. The clearest way to understand it is through Margaret's 3-layer fortress model.
Okay, let's break that down.
So the first layer is IAM policies, which stands for Identity and Access Management. This is identity-based control.
Right, so it starts with the user or the server role and asks, what is this specific identity allowed to do across the AWS account?
Exactly.
I like to conceptualize IA as your employee ID badge. It tells the security desk who you are and generally what clearance level you have.
That's a perfect starting point. But the second layer is where the vast majority of developers trip up.
And what is layer 2?
Layer 2 is bucket policies. This is resource-based control. It attached directly to the bucket itself, completely independent of the user.
So it asks, regardless of who is knocking, who is allowed to access this specific bucket, and under what conditions.
Yes.
So if IAM is my employee ID badge, the bucket policy is the specific keypad on the door of the server room.
Exactly. The keypad is programmed to only let in network engineers, and perhaps only from specific IP addresses.
And the interaction between those two layers is where debugging gets tricky, right?
Very tricky. Imagine you have full administrator access via your IAM badge. You are effectively all-powerful in the AWS account.
Okay, I walk out to a bucket, try to read a file, and get an access denied error. Why?
Because even though your badge says you can go anywhere, the keypad on that specific door was explicitly programmed to keep you out.
Ah, which brings us to Margaret's golden rule of S3 permissions.
Yes. Denials always win.
So if your IAM policy grants you access, but the bucket policy explicitly denies you, you are locked out.
Exactly. And conversely, if the bucket policy says you can come in, but your IAM badge doesn't grant you S3 privileges at all, you are still locked out.
Both layers must agree to permit the access, but a single explicit deny at any layer instantly shuts it down.
Which explains why debugging requires you to look at the resource, not just the identity. You have to check both the badge and the door.
Now, there is a third layer Margaret mentions, ACLs, or access control lists.
Right, but she mentions them primarily as a historical artifact. ACLs operate at the object or bucket level and represent the oldest access mechanism in S3, basically predating modern IAM architectures.
So what is her guidance to Timothy on ACLs?
It's clear. They are largely superseded by bucket policies. You will definitely encounter them in legacy environments, but for new infrastructure, you should avoid them. Just stick strictly to IAM and bucket policies.
That makes total sense. Keep the surface area of your permissions as consolidated as possible.
Definitely.
But Margaret ends this library mentoring session with a rather grim warning about the ultimate safety net. The master switch.
Yes, the block public access feature.
Right. It's an account level and bucket level override setting.
And what it does is remarkably simple but incredibly powerful. It prevents data from being publicly accessible overriding whatever any IAM policy, bucket policy, or legacy ACL tries to dictate.
It is a hard stop against public exposure.
Exactly. And it is turned on by default for all new buckets.
Margaret tells Timothy you should never, ever toggle that switch off without a deeply considered architectural reason. Why is she so militant about this one specific setting?
Well, this raises an important question about the reality of modern software development. The block public access switch exists because the tech industry has a deeply painful history of inadvertent S3 data exposures.
Yeah, we have all seen the devastating headlines.
Millions of voter records or sensitive patient healthcare files just found sitting completely unsecured in a public S3 bucket.
But those leaks rarely happen because an engineer intentionally made the data public.
Right. Exactly. They happened because before this safety net existed, a single typo in a complex JSON bucket policy or a misunderstood legacy ACL could instantly expose an entire bucket to the public internet.
Wow. So companies faced catastrophic regulatory fines and an irreversible loss of customer trust just from like a misplaced asterisk in a permission flag.
Precisely. Block public access is a blast shield.
It's the fail-safe. Even if you completely mess up the keypad on the door and you accidentally hand out master badges to the public, the building itself is just physically sealed off from the street. The data cannot leak.
It is a design decision born directly from harsh industry experience.
You know, this entire conversation radically shifts our perspective on what S3 actually is.
It really does.
I mean, we started today with the 10% illusion, right?
Mm-hmm.
Viewing it as a passive container, a flat namespace with unlimited capacity.
We were just looking at the shape of the tool.
Exactly. But then we dug into the substance. We unpacked the undo button of versioning, exploring how delete markers save us from catastrophic overwrites.
Provided we have the discipline to opt in before things break, of course.
Right, naturally. And then we explored the economic realities of the temperature spectrum with storage classes.
Understanding those latency and cost trade-offs between the hot access of S3 standard and the deep, cold archive of Glacier is just so crucial.
Absolutely. And we saw how lifecycle policies automate that entire journey, basically preventing technical debt from ballooning into massive monthly invoices as your system inevitably scales.
Yep.
Finally, we navigated the three-layer fortress of access control. We broke down the critical debugging logic between IAM identity badges and bucket policy keypads.
We touched on the legacy of ACLs, too.
Right. And the absolute necessity of the block public access safety net to prevent those headline-making data breaches.
You are no longer just dropping files in a box.
Yeah.
You are engineering a data lifecycle.
It highlights a really sobering reality. I mean, think about how many teams are out there right now operating entirely within that 10% illusion.
Oh, paying premium prices for dead data and remaining completely vulnerable to a single bad deployment script.
Probably more than any of us want to admit.
Definitely.
So as we wrap up today's deep dive, I want to leave you with Margaret's parting thought to Timothy as he packs up his notes in that library.
It's a great line.
She tells him, S3 is not a place you put files. It is a design decision.
Such a brilliant reframing of the technology.
It really is. So we challenge you to look at your own infrastructure. If a seemingly simple storage bucket actually dictates the architectural future, the economic viability, and the security posture of your entire application, well, what other simple tools in your daily tech stack are secretly defining the limits of what you can build?
It is definitely something to think about the next time you assume a managed cloud service is just a passive container.
Because as we have learned today, the box is never just a box. It's a complex machine. And you had better know how to operate its hidden mechanics before you put anything valuable inside.